All right, guys, today we're doing lab 14A together. It's the periodic table. We're going to be building the periodic table out of these tiles that I have, like a puzzle, and then we'll be answering some questions about it. So this is lab 14A in your lab books, so make sure you start a new page, all that other stuff that I ask you to do when we normally do a lab. Go ahead and read to you. It says, what is the periodic table and how many elements are there? So chapter 14 is all about the periodic table and its structure and why it's organized the way it is. This lab will help you get a sense of that. It says virtually all the matter you see is made up of combinations of elements. Scientists know of 118, the number is actually going up, of which about 90 occur naturally. So anything beyond that 90 is stuff that's been made artificially in laboratories. They exist in nature, we haven't found them in nature yet. Each element has its own unique kind of atom. That's what makes an element an element. It's all based upon the number of protons. Remember, protons define the element. If you know it has a certain number of protons, you automatically know what element it is. The periodic chart table is the chart that shows all the elements in order of ascending atomic numbers. So as you look at the chart, it starts up in the upper left corner with number 1, hydrogen, then it moves way over to number 2, helium, and number 3, lithium, and then it keeps going across. So as you go from left to right, you add 1 proton each time, which is why the atomic number goes up by 1 as well. We're going to learn some other structure today, all right? So in addition to just going as you go from left to right, the atomic number goes up 1 at a time. We're going to learn about why all the top part of the periodic table is kind of weird and stuff too. And why is that weird bottom part of the periodic table that you guys have at home? Part 1, elements in their atomic number. Every element is given a symbol of 1 or 2 letters. For example, the symbol for hydrogen is the capital letter H. The symbol for lithium is 2 letters, Li. Each element also has a unique number called the atomic number. The atomic number is the number of protons in the nucleus of all atoms of that element. So remember, you might have isotopes, where you might have different numbers of neutrons, but they all would have the same number of protons, thus making them all the same element. We learned in a worksheet that there are 3 basic forms of hydrogen. There's basic hydrogen with 1 proton, there's deuterium, which has a proton and a neutron, and there's tritium, which is a proton and 2 neutrons. They're all hydrogen because they have 1 proton. All right. Atomic number 1 is element hydrogen. The lightest element known is since it only has 1 proton in the nucleus. Atomic number 92 is the element uranium, which is one of the heaviest elements that occurs in nature. Uranium has 92 protons in the nucleus. That's why it's element number 92 on the periodic table. So for this part, number 2, I'm gonna build the periodic table out of these tiles. Now the periodic table, what you see here at the bottom, is how the puzzle is going to look when it's done. All right, and notice this looks very different than any of the periodic tables I've given you so far, and we'll talk about why that is in just a moment. So I'm going to pause the video, get the puzzle out, show it to you, and then I will construct it for you so you can see how it looks. All right, so here we go. So here is the periodic table puzzle box. We look inside, we see we've got all these tiles. Okay. So I'm going to get these tiles out and put them on the table and then show you again. So I'll pause one more time to see what we got. We also have another box that has another kind of periodic table in it, which we're not going to worry too much about right now. We might come back and visit this periodic table at some future time. But for now, we're going to look at these weird tiles that we got and see what they got in common. So one of the things you'll notice very early on is that the tiles have 2 different sides. Every single one of them has a yellow side, and the other ones have different colors. Like there's a brown, there's a dark blue, there's a red. Let's see, I think I see an orange in here. There's an orange. There's a light blue, green. Let's see, purple. Anything else that I missed so far? Oh, dark brown. It's like a tan, and then there's a dark brown. All right. Now, for the purposes of this, there's orange. I don't think I said orange. For the purposes of this puzzle here today that we're going to build, we're only going to focus on the sides that are not yellow, with one exception. There's one that is yellow that we need. The rest of them that are not yellow, we're going to flip over. All right, so I'm going to pause again and do all that work for you and then come back. Okay, through the magic of jumping forward in time, I've got them all sorted out according to the different colors. And you notice that by far the tan elements have the biggest pile. There's a dark brown, there's purple, light blue, orange, dark green, dark blue, lighter green, and red. Now, if you kind of zoom back a little bit here now, there's all the tiles that we'll need to build this. Now, there are lots of extras. Like if we zoom in here on the dark blue group, you can see there are several Ks and a couple of N's there. So K is potassium, Na is sodium. So next I'm going to pause. I'm going to get rid of all the extras, and we'll get our pile down to the final pile we'll need to build our periodic table. Notice that when I get rid of the extras in our non-tan piles, we get down to just a few of each color. We're going to continue sorting now. Okay, now I have the tan ones all sorted out here now. So we got rid of all duplicates. And that revealed to me finally then our last and lone yellow one, hydrogen, number 1. Okay, the next step would be to get these all in numerical order, because every single one of these, you know, has their atomic number on them. Okay, so we're going to put them in colors, keep them in colors, and we're going to separate them and put them in ascending numerical order. So we're going to stop and do that real quick, and you see what that looks like. All right, now here they are, all sorted out according to color and increasing number. So the only yellow, 1, and then we got our kind of, it's actually orange in real life, looks a little pink here, but we got 2, 10, 18, 36, 54, and 86, so keeping those in colors. You can see the dark blue. Again, as we go this way, they get higher and higher, but they stay in color. What you may notice when I line up this way, we got 2, 3, 4, 5, 6, 7, 8, 9, and for the most part, these columns start to count up too. That'll come into play later on. Then finally, when we get to our tans, I had to make them in 2 different rows to make them fit all into one desk. So if I pan back a little bit here now, you can see the whole thing there fits on one big desk. Now, that is still not the same thing as that. That's what we're going to build here now, okay? So I'm going to pause one more time, and I'm going to start to build this, and I'll kind of show you how it comes along every so often, all right? I'm going to build it on a desk by itself. So I got the first tin laid out. So notice we start over here with hydrogen, lithium, beryllium. We go over here, and we get these other ones. Notice how these orange ones are starting to stack up, going up and down. All right, that's going to be true, as you'll see later on as we keep going. So here we go. Okay, so here's that shaping up so far. So notice over here, we got 1, 3, 4, 11, 12, etc., etc. If I come down here, there we go. 1, 3, 4, 11, 12, etc., etc. Going back up here, you can see that we got 2, 10, 18, 35, 54, and 86. So if we come down over here, again, I have that same thing going on. So notice again, the columns are the color code key here by and large, with a couple exceptions as you'll see later on. So once again, we're going to pause, do a little more building. So what that gives us now here is, again, all the color codes in columns. And these color codes here, which we're going to, are different than what I had you do the other day, but still represent the same idea, are what's called families or groups. Groups or families, you'll see both terms used, are columns on the periodic table where all the ones in the same column, or the same color code in this case, have similar chemical properties. They're going to form reactions in ways that are going to be similar. And we'll be getting to that more this year too. Notice we got a big gap here in the middle now, and that's where every one of these bright, light tan ones come in, all right? So if we go back up to the board, you see we've got everything over here. Boom. And although it wasn't filled in with numbers, let it focus, we've got everything over here now. That's what this part is. So now the part comes in filling everything here in the middle. All right. So I'm going to start working on that next. I'll pause and we'll come back once again. Okay. So now look here. It says 21, then a bunch of blanks all the way over to 36. I have done that now. There's 21, 22, 23, etc., going across. We transition back into purple, 31, 32, 33, 34, 35, and 36. So we've got this part right here now. So I'm going to pause again. All right. Now, once again, we got element 39 going across to element 54. Looking down here, that's what I've got now. Element 39 going across to element 54. So going back to the periodic table here now, all that's left now is all of this stuff here in the middle now. From there, this big gap over here that's now not quite filled in. We're going to fill in here in just seconds. Once again, I'm going to pause, Come back in a minute. All right. So there's what our final periodic table is supposed to look like. And I'll scroll down here. We'll zoom back out a little bit. And you can see that we have it now. Boom, boom. Going pretty fast here, all right? Now, one thing I want you to notice is that most periodic tables, like this one here in my room, that you've probably all glanced at least once or twice here now throughout the school year, and the one that I've created in the hall has got this weird section here at the bottom. But notice the arrows say it's been pulled out over here, all right? So that is this section right here. So we pull this whole section out, move it out, and then put it underneath the periodic table, and then take this blue section and smush it over, boom, to get the periodic table that you're normally used to seeing. Okay? So we're going to pause again, go back up to our lab book, and answer some questions now based on what we saw. Now, when we do the rest of our chemistry studies this year, we're going to focus on everything that's pretty much not tan. The tan section has got a lot of weird things going on. You'll learn more about that in high school and maybe college chemistry. We're going to be focusing on everything that's a color other than tan, for the most part, for the rest of our school year. All right, so keep that in mind as I pause again and we go back to the board. All right, so we've made our periodic table puzzle. We've got it laid out like this. Now there's some questions to answer. So, question 3A. It says, many printed periodic tables look like the diagram on the right. So let's talk about this before we came back here. So, I pulled out that one section, which was up here. Oops. This section here gets pulled out and brought over. Okay? That's what you're seeing here in this diagram. It says, can you think of a reason why? Why would we pull this section out and mush it over? Recall that the entire periodic table that I built on the table took up an entire desk. So what would be a practical reason why we might pull this section out and smush this part over? Think about that. You can look it up. It's also in the book, I believe, as well. Part 4. It says, the periodic table is organized into 11 sections shown as A through K. Each section contains elements with similar chemical properties. Most sections are single columns. One section includes many columns, and 2 sections are part of an entire row. So what they're talking about is section A, B, F, G, H, I, J, and K. Those are the ones that when I built them were colors other than tan. So we had hydrogen, which was yellow. Then we had the dark blue. We had beryllium in the light blue section. Then we had the purple section. Then the red. Then the dark brown. Then the light green. The dark green. And this was the orange, or it looked pink on the video, I thought. So C, D, and E are all the tan ones that we had on our periodic table later on. So if you need to go back and freeze frame the video to see the whole thing, you can do that. It says A, locate the element that is first one in each of the following sections. So we're talking about this one. Oops, maybe not. Let's see. Try something here, see if it works again. Okay, it's not going to work today, but okay. So the top one here in A, the top one of B, top one F, G, H, I, J, and K. For E, we're talking about this one here, C, this one here, and D, that one there. So locate the first element in the following sections. Research the name, if any, for this section, and research any properties and elements this section shares. So what you're going to do is have to make this table. Table 1 here. And it is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 by 12. And the diagram refers to the diagram on the previous page. You can scroll back to see that. The first element is whatever is there. So for example, this first one for A was hydrogen. It was the top of that first dark blue row, the only yellow one we had, hydrogen here. B, the first one was beryllium, the top of the light blue row, etc., etc. Section name. All right, so what you're going to want to search for, listen carefully for this one, is that you're going to search for the name of the group. So the hydrogen group would be what you search for. If it has a special name, you'll find that out. I believe it's also in your book too. All right, the beryllium group. Okay, search for beryllium group. If that group of light blue ones has a particular name, that will tell you that. A lot of them don't really have a special name. They're just the name of the first one at the top. But some of them do have special names. So take the time to try to look that up. It's both in your book and you can find it online. Then it says representative chemical properties. So you'll need to look up on this one too. You can search for properties of whatever the name of that group was. So for the first one, I'll go ahead and give it to you. So the first one was hydrogen. A was hydrogen. I can't write the board, unfortunately. The section name, those are called the alkali metals, like an alkaline battery. Alkali is an old term that means what we would usually say today as a base. A base is the opposite of an acid. We'll learn more about that this year too. All right? So there's hydrogen, the alkali metals, and some representative chemical properties. You can look up properties of the alkali metals, and you should be able to find a couple of things, but at least a couple of things. So this is properties, so that implies more than one. So some sort of thing that they all have in common. Like things like, are they very reactive or not? Do they tend to form bonds with certain chemicals? Are they all metals or all non-metals? Do they all have a similar look? So look up properties of each of these columns and put something here. All right. So again, some of these don't really have a section name except for their first one. For example, if we go back up here, Group F. All right. Group F. I'll tell you this one real quick. Group F. The top one is boron. It's called the boron group. It doesn't really have a special name. So this was hydrogen, the alkali metals. This is boron and the boron group. All right. I'll give you one more. If we look at section C here, this long strip of light tan ones that goes across, it begins with the element, lanthanum. So these are called the lanthanides. So this is lanthanum. That is lanthanides. Look up the properties of the lanthanides. Go ahead and do D too. D is actinium. These are the actinides. So D is actinium, actinides, and then find some properties of the actinides. All right? So that's your challenge. That's what's going to be the biggest part you have to do on your own for this lab. Part 5, applying what you've learned. Some questions you'll need to answer at the end. This is each row of the periodic table contains only a certain number of elements. What does this have to do with the structure of the atom? Research this question in your textbook. All right, I'm going to change the angle of my camera here in a second and show you this one. Okay, notice that the first row going across has only two things, hydrogen, and over here you have helium. Only two things. If you think back to your atom game, okay, the first circle in the atom game only had 2 marble slots, didn't it? Okay, look at the next row. Okay, you have 1, 2 over here, and then you have 3, 4, 5, 6, 7, 8. So the second row going across has 8 elements. I do believe that on the marble game, the atom game, the second circle, the second electron circle, had 8 marble slots. If you look the next one down, it begins with sodium, number 11. 1, 2, going across. Again, 3, 4, 5, 6, 7, 8. So there's 8 going across there. A third circle in the atom game had 8 marble slots. So if you remember the atom game, you also be able to tell me now how many marble slots were in the third row going across and the fourth row going across. Okay? Or the fourth and fifth row going across. And that's as far as our atom game went. Our atom game basically only allowed us to build things up through xenon, was the highest one we could build. Because then you start getting down here in this bottom row where there's so many things going across that you'd have to have a much bigger game to be able to play it. So there's a definite reason for why those things are laid out, going across the way they are laid out. Okay, look it in your book. I just gave you a giant hint. B, which section of the periodic table above contains the element argon? What characteristics do the elements of this section share? So it's a similar question to up here. When you find the one that had argon in it, if you look at your periodic table, you can be able to tell which column it was in. Argon is going to be in one of these columns here, A, B, F through K. It's going to be one of those. So whatever answer you put for that group here will be the same answer you put down for 5B. C, which section contains the element carbon? What characteristics of the elements in this section share? So B and C, you can get from the table above. And that brings us to the end of the lab. Okay? So that's all you have to do. Make this chart, do a little research, answer these 3 questions, and you have done lab 14A. All right. Again, if you have any questions about anything you saw here today, don't forget you're watching a video, so you can always rewind, pause, anytime you need to be able to look at things more closely. But if you have any questions beyond that, let me know. Hope you guys are staying well, and hopefully I'll see you soon.